So we have two circles. Let me see who's on right now. Looks like Sardar had to go. So we have two circles. They intersect at points B and C. So I'll draw it like this. And actually, I could just do it like this. So these two circles intersect at B and C. And then we have another circle that's tangent to BC. So, and it's also tangent to the first circle at N. And then we try to see where it intersects this circle. So basically, I'm going to take the midpoint of EF. Which is G. That's going to be the center of the circle. Whoops. Sorry. There we go. Let me try to make this look a little better. I want G and A to be farther apart. I don't know if it's that easy to do that. How do I make G and A farther apart? I'll just leave it like that for now. So it intersects omega 2 at S and T. So this is S. This is T. And then NA intersects, oh wait, it's tangent to BC at A. So this should be A. And this should be N. So then we say NA intersects ST at an omega 1 at M and Q. So there's a lot of points here. So this is Q. And this is M right here. Whoops, sorry. I'm going to hide some stuff. So we want this to be M, point M right here. Whoops, it's having trouble drawing it. Let me zoom in a little bit. There we go. So that's point M. And P is the point on omega 1 opposite of Q. Wait, isn't that this point? Now I'm confused. Maybe I'm not drawing this right. We have two circles that intersect at B and C. And we have another circle that's tangent to BC. Oh, but it might not be at the yeah, okay. This is maybe not the best picture because circle, it could be tangent to BC at some point that's not like the midpoint. So I'm not even sure how I would how I would draw that, how I would be able to figure that out. Yeah, I need to draw this differently. Actually, that's okay, but I just need to delete a whole bunch of things. So because yeah, it could be like tangent at this point for example. So what I think I would want to draw this diagram, I would want to invert a bunch of stuff. So yeah, what if I try inversion? Yeah, so I'm just gonna come up with a rant. I'm gonna do it like this. So I could try inverting about A.
No. You don't need to inverse. You just let QA cut the circle A1 at the another point. Yeah,
Okay.
and the circle mm, yes. So circle let the uh I do not know how to let the bisect perpendicular bisector of EA cut A1 A1 A1E. Yeah,
Okay.
that will be the center of
Ah,
the yeah.
okay. So let's see. So this would be the center of the circle.
Yeah.
So AF should be perpendicular to BC then. All right. Okay. Because yeah, that makes angle FAB has to have to be 90, and so that would solve the problem. Okay, so all right. So we have a circle there. Let me call this O. So it's tangent at A and it's tangent here at N. And it intersects, okay, so S and T are those 2 points. And this is point T. So NA intersects ST. Okay, so let's draw the line NA. Oh, yeah, so Q, we actually had Q, right? Q is the correct, so NA and Q are collinear. We just have to, so draw ST. And that's point M. And P is, so this is P right here. and PA intersects omega 1 at R. And RN intersects BC at Z. This is a tricky diagram. Let's see.
I think that you should move point D far over the line BC. It would make the diagram more bigger.
Move D farther away.
Oh no. Oh yeah. Yes, that will make the diagram look easier.
Okay.
Okay.
Okay. We want to show that CS, MZ, and BT are concurrent. So yeah, I think I'll try. So yeah, right now PQ looks a little tilted. I want PQ to be horizontal. But then let's see. I want AC to be I want this to be vertical. Okay. CS, MZ, and BT. Kind of feels a little bit, I wonder if the point they pass through some special point. I don't think so. I was going to say maybe use Pappas or something. Let's see. So I highly doubt that but let me check if CSMZ is cyclic. No. We try to show, I was thinking maybe the SARGs, like we could show PZS and BMC are perspective. think that would be hard though. Yeah, this one looks like it's going to be hard. Let's see. So looks a little bit like Pappus, maybe even Pascal's theorem. What if I let BT intersect CS at a point? And then I want to show that that's collinear with M and Z. Kind of like that. Yeah, it looks like Ricard's it might help. I just don't know how to use the tangency of N. Yeah, I'm not sure here. Let's see, I'm going back to trying to use Pappus. So what if we let Rn intersect? Looks like Animal had to hop off. Hmm. So we could try to use like Pascal's, we could try to use Pappus. We could try to use radical axis theorem. I wonder if maybe we could use poles and polars. Because Let me see. Yeah, I wonder if the polars of E, M, and Z concur. Maybe that would be a way to show it. Animal. I see you just came back. So yeah, I could try to show the polars of E, M, and Z with respect to this circle are concurrent. Or maybe, yeah, it's weird because it's like we're trying to use Ricard on 3 different circles, right? Because M is the intersection of the diagonals in this circle, Z is the intersection in this circle, and E is this third circle. That's what makes it hard. So I wonder if QR, PN, and BC are concurrent. Ah, that looks true. Is that obvious? I think that might help a lot. Oh, is it? Is it obvious? Yeah, I think it might be obvious. I think it feels similar to that problem from Indonesia, actually. Oh, no, but that one was like the tangents. But yeah, so if we use Ricard's theorem, then PN, BC, and QR are concurrent. You could draw it like this. Maybe that might help. Let's see.
Michael.
Mm-hmm.
So if we let the tension of the O at N, yeah, cut the tension at A, yeah, at
Okay.
yeah, at one point. Yeah, and if we could prove that HR is the tangent of the circle O,
Okay.
so we will solve the problem.
That would solve the problem if HR is tangent.
Yeah, because if HR are tangent, so Z BC will be harmonic, and because HA is the tangent too, so HTMS will be harmonic, right?
So HTS and M would be collinear.
Maybe we need to prove that.
Okay.
We need to prove that. Yeah.
Interesting. Seems like a good idea. So yeah, I like that because it uses the tangent at point N. So we need to show the tangents at N and R meet on AB.
That is because when we use the what do you call PowerPoint, the of three circle F, circle O, and circle D, three radical axis. Yeah, the three radical axis will be concur. NH tangent at N will be radical axis of circle F and O, right? TS will be radical axis of circle F and D, and BC will be the radical axis of O and D.
Okay,
Yeah,
so TS passes through H.
Yeah. As well, yeah, TA will be the tangent.
So HN is equal to HA. Oh, I think so we could show HN is equal to HA, which is equal to HR. That's probably an angle chase, right? We want to show H is the circumcenter of NAR.
Okay, so now I solve it. If we can prove that NRBC are the harmonic quadrilateral, so HR will be tangent to the circle O, right? Because H is the intersection of tangent at N and BC.
Yeah, we want to show NBRC is harmonic, is what you're saying, right?
Yeah, and if we use A, when we use A, we project A to the circle O. So we need R will become P, N will become Q, B will become C, and C will become B. Yeah, and P, B, Q, C is harmonic. So N, R, B, C are harmonic too.
Okay, so so N goes to so because PBQC is harmonic, then NBQC is harmonic, which means that the tangents at N and R concur on BC at a point H, and then you can use the radical axis theorem.
Yeah. First, we will say that because of the radical axis, so TS, BC, and the tangent at N is concur.
Yeah.
Yeah. So and next we will prove HR are the tangent too.
Okay. So,
Yeah.
so I see how that all works. So HR is tangent, and this is collinear. And then how do you use that to show the final part?
So if we have that, so HMTS is harmonic, right?
Mm-hmm.
HZBC is harmonic too.
Okay, that makes
So
sense.
TBCS and MZ will be concurrent.
Interesting. All
Yeah.
right. So this is harmonic, and this is also harmonic.
Yeah.
So that's a nice solution. So you don't really need point G.
Yes.
Let's see. Yeah, let me hide point G. That was easier than I thought.
No, it was kind of difficult to look at to find out the tension at N.
Yeah.
Yeah, and it's difficult to find out that we have to use the harmonic. I find it because they didn't say the TS or ST. So if you you let the T is the S and S is T, so the problem will be it don't so right. So I think of about the harmonic. Yeah.
Interesting. Okay, so let's write it out. So let the tangent to both circles at N meet BC at H. And now we can apply the radical axis theorem. So by the radical axis theorem on the three circles, ST passes through H. And then we want to show, so PBQC is harmonic. And that's, I mean, that's obvious. I'll just say by symmetry.
I think we should say that NA Q is the midpoint of arc BC, so it will be harmonic.
Oh yeah, actually, we still have to prove that NA and Q are collinear, right? So you mentioned that earlier. So yeah, we have to prove that Q is the midpoint of arc BC.
That is kind of obvious because when you see
by homothency.
Yeah, homothency of N. So QO will be perpendicular to BC, and so Q will be the midpoint of arc BC.
Okay.
Yeah.
So by homothency at N, so a homothency at N, it takes A to Q.
And F to O.
A to Q and F to O.
Yeah, so OQ will be parallel to FA.
It takes A to Q and F to O. So that means that so because AF is perpendicular to BC, yeah, that means QO is is parallel to AF, which means that QO is perpendicular to BC. So, sorry, so, QO is parallel to AF. And that means that QO is perpendicular to BC. And I think Daniel was just about to join, but he hopped off. And that means that Q is the midpoint of arc BC. And then, okay, so yeah. So now we have PQBC is harmonic by symmetry. So projecting through A. So you can project through any point, whether or not it's on the circle, right? So projecting this quadrilateral through A. Then we find that NBRC is harmonic. Oh, hold on just 1 second. And then that means that HR is tangent to the circle omega 1. Okay, so we have HBAC is harmonic. We'll say, and BCAH is harmonic. And then we also know that TSMH is harmonic. How do we know that? Oh, because NTAS is harmonic.
Yeah, because NTAS is harmonic. Yeah.
So.
No. Michael. BCZ, BCH, HZ.
HZ.
Yeah. Not A. Yeah.
Right. So NTZS is harmonic. That means that TSMH is harmonic. And then combining the above two, we know that BT, ZM, and CS concur. All right. Very nice solution. I like it. I like how you use the tangent at N. Okay. Oh, we already did this one. Okay. I'm going to search for some more problems. Hold on 1 second. Let me So I think Serdar posted one other. You guys know any good competitions? I'll look at ELMO. Let's see. Oh, this one, someone posted the answer to it on Discord. But I didn't solve it. Did you guys solve it?
What? Yeah. Just pick it.
Okay. Yeah, I know Serdar already solved this one, but he just hopped off. So this is a good one, I think. Don't look at the solution though. Somebody might, yeah, close your eyes for a second. Yeah, this is a good problem. So I know Serdar solved this on Discord, but it'll be interesting to see if we find the same solution. All right, you guys can open your eyes if you want. So we have a triangle ABC, and it's inscribed in a circle omega. And then we draw the medians from B and C. But we don't want, so I'll call these midpoints something else, maybe M and N. Whoops. And then it intersects the circle at D and E. And then we draw the circle through D tangent to AC at C. We've had a lot of problems like this today. So through D tangent to AC. So this would be the center of that circle. And then I could draw the perpendicular on the other side. So through E, so tangent to, okay, so this is the other point right here. And then we want to show GF and the 9-point center are collinear. So I'm going to draw the 9-point center. All right, let me make it a little nicer. So I want to, let's see, it almost looks like GIF is parallel to BC, but it's not true. So yeah, let me draw that segment. We want to show that these are collinear. Let me try to draw it so it doesn't look parallel to BC. So if yeah, if it's a taller triangle, then it doesn't look as parallel. Kind of like that. Maybe I'll just draw like these as like rays, just so it's like clear that these circles are tangent. So yeah, obviously these are all the altitudes, those other points. That's O2, this is O1.
Could you draw H and O as the ortho center and the center of circle ABC?
Mm-hmm. Let me rename some things. I want the 9-point center to be N. Whoops. So here's the altitudes. I like this diagram. Whoops. That's H. Let me delete this segment just because we're trying to prove it, but yeah, so we want to show that.
Hold up. Could you draw the midpoint of O2, O1? I think it will be N.
Ah, okay.
Yeah.
Yes.
Yes. So we're gonna prove O2, O1, O and H is what parallelogram, right?
Ah, okay.
Could you change the name of F? It should be O. Yeah. It will
Okay.
be easier to look. So here's the thing. I think we must prove that EB is perpendicular to O1H.
ED is perpendicular to
O1H, because O12 is perpendicular to EB, right?
Wait, let me make sure. So did you say O1H?
Yeah, it's perpendicular to EB.
Oh, EB.
Yeah.
Sorry, I thought you said ED. I was confused. Okay.
Yeah.
But we know EB is perpendicular to O2, right?
Yeah. We must prove that.
Okay. So N is the midpoint of OH. So Is it? Oh, and the centroid actually also lies on this, right? I don't know if we use that, but that's true, right?
Yes.
So yeah, if we want to show that's a parallelogram, yeah, then we want to show EB is perpendicular to O1H. Um, it's interesting. So we know that O1C is perpendicular to AC. So could we show that the angle between EB and AC is the same as the angle between O1C and OH? Not sure. But I like your idea. I think that seems like a good way to do it. Maybe we could use some medians or something, because let's see, CE is a median. So yeah, what if we drew this median? Okay, so let me try something. Yeah, this is interesting. Um, I wonder if ECB is similar to O1AH. Let's see. I have to measure it in the right direction. Oh, that's 52.51. No. But do those add up? No. It's not gonna work. I don't know if it's worth drawing like if I label like the midpoint of DC. Is FM tangent to the 9-point circle? No. But FM is parallel to AD. So let's see. Just gonna erase that. Yeah, we want to use that tangent somehow. And also O1C is perpendicular to AC.
I think we should prove that O1M and E is collinear.
O1M and E?
Yeah.
Interesting.
Yeah, if we prove O1M and E is collinear, we will prove that O1H. Oh, they are not.
They're not.
Oh, my bad, my bad.
Interesting idea though. Yeah, because O1L, O2L, and B are not collinear. Oops. I wonder. Yeah, is there a spiral similarity that takes like triangle BEC? Like, what if we do a spiral similarity with 90 degrees? That takes like yeah, I wonder, like, what if I let LK meet BC at a point? What do you think about this? So then AI is perpendicular to PH. I don't think that does much. Yeah, O1H, it's hard to find O1H. So what do we know about the orthocenter?
This idea is kind of difficult to prove.
Mm-hmm.
Did you have any other idea?
I'm not sure. What if we draw the perpendicular? I guess we could try this. Draw the perpendicular to O1H through H and let it meet AC at a point. So then we have IHCO1 is cyclic. And we want to show IH is parallel to BE. But yeah, I don't know how good that word that is. I wonder, let me try something. Sorry. So angle ECB is 41.54. No, those aren't equal. Okay, yeah, I don't think that works. Let's see. But it seems like that's the best way to do it, right? To show that O1H is perpendicular to BE. So O and H are isogonal conjugates about C. And O1O is perpendicular to DC. So what if I drop a perpendicular from H to BE? You know what? Maybe this is just an idea I had. So draw perpendicular from H to BE. Basically, we want to show that three perpendiculars concur, right? I wonder if there's something, you know, orthologic triangles. So we want to show HIOF and the perpendicular to AC concur. Maybe I could use like stuff about homophoties. I don't know, like the midpoints. Okay, so we want to show O20O1H is a parallelogram. Okay, I just thought of one other thing. So I wonder if we take the midpoint of BE, O2R. No, that's not cyclic. Wait a sec. It almost looks like, no. So yeah, what do we know about BE? Yeah, this is hard. Let's see if the Bayou can help us. Hi, Bayou. Thanks for joining us. So we got through a bunch of problems, but this is like the hardest one. So maybe you have an idea. Hmm. This is so tricky. So I have an idea. Let me think about this. I'm trying to use ideas on orthologic triangles. So you look at triangle HCO. So we have CD, BE, and ACE. Okay, actually, I'm not sure if that'll work. Let me try something. I have an idea, but it's really hard to get it to work. Wow, this is hard. I wonder if maybe we could do stuff on X centers. So if O1H was perpendicular to BE, then we could like reflect. We should be able to reflect both across something. I want to let BE and CD meet at a point. but it's hard to make a nice picture that way. Because we want to show angle HO1C is equal to the angle that these make. But yeah, it's hard to get a good picture where they intersect closer. That's the thing. If I zoom out a lot, it's just, yeah, it's really tricky. But yeah, it's very hard to get them to intersect. What if I did something like this? Oh, you know what? I need to make a triangle like that. I want them to intersect. Okay, so, but I don't want H to disappear. That's the thing. My bad. What if these two intersected above point A? So like, what if I had a figure something like this? But where's H? Thing. I don't want H to disappear. Oh, H disappears if it's past point G. It shouldn't, but oh well. There are two animals now? Yes. Maybe animals on his phone and computer. Sorry. Hey, Animal, you're on video, just letting you know. It's a good problem. We need some similar triangles somewhere, I feel like. So BE, if I draw this point right here. Oh wait, never mind. What's the midpoint of EH? So it should lie. So if R is the midpoint of EH, R is going to lie on the circle. Then we could try to show PR is parallel or perpendicular to O and H. You know what? What if we did this? So what if I, this is just a guess, but I want to make H the center of a circle. So I'm gonna, this is looking interesting. So these look like they concur. So basically, I draw a triangle. So triangle R, S, and then I could call it T. So H would be the circumcenter of RST. So RST is like the double, is like the twice the size of ABC. And then H is the circumcenter of RST. I don't know if this is actually going to work, but it's just an idea. And R and S lie on those two circles, so maybe that would help. So H is the center of that circle, RST. And so OH, if we draw this other intersection, if we draw the other intersection points, then O1H is perpendicular to SU. So maybe we could show SU is parallel to BE. I kind of like that. So G, let's see, I think are G, P, and T collinear? Yes. Actually, yeah, I think this might get us close. So A, G, P, and T are collinear. These should be collinear. So we want to show FU is parallel to BE. So angle DSU. Let me try something. Oh, wait, it looks like U is collinear with all those points. Yeah. So if we know that, then if we want to show SU is parallel to BE, we could try to show angle SUE is angle BEU. And SUE is DCE. Yeah, so if we can show these things, that would solve it. Basically, we want to show that U, okay. So can we show, so I'm going to delete some stuff. So can we show that SA
Michael, what is S? How can we define S?
Yeah, S is where so we draw the parallel through A to BC and the parallel through C to AB.
Yeah. Okay.
And then they meet at S. And then can we show that S lies on this circle? Is it obvious?
Let me check it.
Mm-hmm. And then once we show that, if we want to show that U, C, and E are collinear.
Okay. S is lie on the circle O1. This is because the angle DSC is equal to angle ABD.
ABD?
Yeah, because ASCB is a parallelogram, right?
Mm-hmm.
Yeah. So CSD will be equal to ABD.
Oh, I see it now. Yeah. Okay.
Yeah.
So that proves that S lies on the circle. And then once we know that, if we let U be this other point, can we show that U, C, and E are collinear?
Let me check.
Okay. Or yeah, U, C, and Q.
Okay, so yes, if U, C, and R and E and Q is collinear, that is because when you call U as the intersection of the circle TSR and circle O1, so angle SUC, right, will be equal to angle ACS. Because AC is a tangent, yeah.
Oh,
ACS,
we're using the tangent again. So that's
yeah.
ACS.
And ACS will be equal to BTC. That is because AC is parallel to BT.
Okay.
Yeah, and that is RTS. And because U is lie on the circle TRS, so RTS is equal to RUS. So RC and U is collinear.
And then from there, the problem's easy to solve because US is perpendicular to O1H.
Yes.
And then
SU is parallel to BE.
Mm-hmm. All right, I like this. It was a nice teamwork, team solution.
Yeah.
So I'm not going to type it up just because we're almost out of time, but I'll leave it to the viewers. That was a fun one. We'll have to see how it compares because there was another solution on Discord.
Yeah.
All right. So
Nice. The way that you draw the parallel line, it is cool. Yeah.
Yeah, I was trying to make H the center of a circle so that I could make O1H perpendicular to something. And that was my idea because we want to show O1H is perpendicular to BE.
Yeah.
Interesting.
That's cool. Yeah.
All right. Well, thanks everyone on YouTube for watching, and thanks everyone here for participating. So as always, if you want to join it, feel free to email me at mgreenb801@gmail.com. The sessions they're at 8 a.m. US Central Time. Have a good one.